Hi guys, welcome to Amateur Chemistry. So in today's video, I decided to take a break from doing big projects and instead I want to focus on a pretty interesting chemical, which is the supersensitive nitrogen triiodide, also known as touch powder. Nitrogen triiodide is a black crystalline compound that doesn't look too remarkable at the first glance, but on the molecular level, it has a very weird and unusual structure. As the name suggests, it is composed of 3 iodine atoms held together by a single nitrogen, and if we look at its structure in 3D, we can see that the 3 big iodines are bound to a tiny and weak nitrogen, which has a lot of trouble holding them together. This, among some other things, makes this compound incredibly unstable. It is one of, if not the most sensitive compound known. Some sources say that the infamous azido-azide is more sensitive, but as many people tested, it's not really the case, and as we will come to see later in this video, nitrogen triiodide is just nuts when it comes to the sensitivity. You might think that the synthesis of this extremely unstable and strained compound is difficult and requires some exotic reagents, and while for obtaining it pure that's true, but for the equally scary ammonia adducts, this synthesis requires just some elemental iodine and ammonia, which are very common and easy to access reagents. However, despite this compound's accessibility, it shouldn't be made without appropriate safety measures, because while nitrogen triiodide is not too powerful of an explosive, and its sensitivity makes it unsuitable for nearly all explosive applications, it can still do a good bit of harm if handled unwisely, and its synthesis should only be performed by trained individuals. And this video is for educational purposes only. I made the nitrogen triiodide just to showcase its properties, and this video is not a tutorial. Anyway, I can source the ammonia from the cleaning supplies aisle or a chemistry supply store and buy the iodine for cheap in an online shop like eBay. I already have a lot of it, but I decided to show how to make it because it's quite easy and iodine is really useful in a lot of different chemical reactions. The most common source of it that an average person can get is either povidone iodine, which I plan to extract iodine from in a separate video, or an alkali metal iodide like the sodium or potassium one, and I just so happen to have quite a bit of potassium iodide, and to start the synthesis I got my trusty scale and weighed out 15 grams of potassium iodide and then dissolved it in about 30 milliliters of distilled water. With the potassium iodide solution now ready, to move on with the procedure, I measured out 25 ml of 34% hydrochloric acid, which roughly corresponds to the volume of the potassium iodide solution, and then combined both solutions, which made the mixture take on a suspiciously yellow color. A lot of something also precipitated out, and this should be some potassium chloride, but I am not sure exactly what it is, because the hydrochloric acid shouldn't react with the potassium iodide, so I might just be lowering its solubility. As the next step, I have to oxidize the acidified potassium iodide with an oxidizing agent like hydrogen peroxide. It is really cheap and available in most countries, and it doesn't really have to be that concentrated. I use some store-bought 12% one, but 3% should also work fine. I measured out about 100 milliliters of the 12% peroxide. It is a rather large excess, but it won't affect the reaction that much, and when there is not enough of it, the reaction won't even work, because all the created iodine will dissolve and leave you with some brown water. Anyway, I now have to combine these solutions together, and it's important to do this under a fume hood or in a well-ventilated area, because a small amount of toxic chlorine gas will be produced. Upon combining the solutions, everything immediately changes color to brown, indicating the creation of iodine, which quickly sinks to the bottom as this black sponge. To get it out of the beaker, I first drained the brown water off and washed it a few times with a lot of distilled water to get rid of any unwanted byproducts. When I felt that the iodine was clean enough, I got it onto this petri dish. It resembles this wet black sponge and is probably still a little contaminated, but for making the nitrogen triiodide, it will be just perfect. To confirm that I actually made the iodine and not just some random black sponge, I combined it with some magnesium powder that resulted in this nice purple smoke, which confirms that what I made is actually iodine. Another thing characteristic of iodine is that it tends to stain everything around it because it very slowly evaporates at room temperature, and it does an unimaginable amount of damage to my white background, but fortunately I can reverse it by making a solution of a chemical called sodium thiosulfate, which works like a charm and quickly removes all iodine stains. Okay, so now that I have the iodine, I can make the nitrogen triiodide. To do that, I got a plastic petri dish as my reaction vessel, because you don't really need to use glass when working with sensitive explosives. To start making the nitrogen triiodide, I fill the petri dish with some 25% ammonia solution. The concentration doesn't really matter here, and almost any other concentration of ammonia should still work fine. I then proceeded to add my homemade iodine into the ammonia. The addition generated some bubbles of hydrogen gas, and this black powder, which is the nitrogen triiodide. When it comes to the reaction going on here, the iodine displaces some hydrogen from the ammonia, forming nitrogen triiodide, which forms an ammonia adduct and precipitates in the form of these small black crystals. It also doesn't explode in the petri dish because it is wet. As long as it has some moisture in it, it is very insensitive, and this allows me to transfer it onto a piece of paper to dry, which takes quite a while. I checked it with a stick every 20 minutes or so, and after 2 hours, the powder finally detonated. The explosion made a really loud noise and left a small hole in the paper. It also made a nice cloud of iodine vapor, which looked kinda like a nuclear mushroom cloud, but overall it wasn't too powerful. This gave me the courage to test out some different things as the initiators. I first wanted to use a laser, but I unfortunately didn't have one stronger than a laser pointer, which did absolutely nothing. I can achieve better effects using, for example, a feather, which does a really good job at initiating the detonation. Nitrogen triiodide is also the only compound known to explode on exposure to alpha particles, and that means that if I put, for example, a piece of uranium next to it, it would explode, which is really cool. When it comes to the decomposition reaction, the nitrogen triiodide decomposes to elemental iodine, ammonium iodide, and nitrogen gas. The first two of these are responsible for the purple cloud it makes. The elemental nitrogen is also one of the reasons why the nitrogen triiodide decomposes so easily, because along with the high strain of the molecule, its decomposition products are really stable. To see the decomposition better, I recorded the explosion in slow motion, but it was so fast that even at 100 frames per second, you can barely see anything. Okay, and now it's finally time for the thing that I have been waiting to do for years, and that made me do this whole project, and that is an explosive mosquito trap. I want to take revenge on these little mother suckers that fly around my lab and feed off me. I think that nitrogen triiodide is the perfect way to kill them and revenge the liters of blood they stole from me. To make my dream come true, I prepared another charge of nitrogen triiodide, which I enriched with some lactic acid because it is naturally present in our sweat and mosquitoes are supposedly attracted to it. When the mosquito trap dried, I waited for several hours for a lucky mosquito to land on it, but despite there being a lot of mosquitoes in my fume hood, no one showed up, so I had to pick one myself. To get a mosquito that won't fly, I located one on the wall of my fume hood and smacked it with such finesse and skill that it was still alive but couldn't fly anymore. I got it onto a spoon and carefully placed it on the trap. It took a good few minutes of it walking around, but eventually the trap detonated, and in one flash the mosquito was gone. I must say that it is really satisfying to kill a mosquito this way, and this is one of the reasons why I love chemistry so much, because just how cool is it to rip apart a mosquito in a cloud of toxic purple smoke. Anyway, for the next experiment I wanted to make an improvised nitrogen triiodide projectile launcher, so I got a rather large amount of it onto a piece of wood and allowed it to dry. I then very carefully placed a cardboard tube onto it, which fortunately didn't set it off, and then proceeded to throw in a wooden cube to initiate the triiodide, but to my surprise, it stayed completely intact. I tried to help it using a heavy battery, but it not only didn't set it off either, it also threw apart the entire build, which I then assembled again, and I was really surprised that it didn't go off for so long. It took another 2 tries to make the thing finally detonate. What's funny is that the battery didn't go inside it, so everything just fell apart with this purple smoke, which made it look really cool. For the last experiment, I wanted my workspace to look clean, because after all the experiments it looked like it got insanely moldy. There are also a lot of stray crystals of nitrogen triiodide on it, as well as on the floor, and I know that because when I'm walking next to my fume hood, I hear these nice little explosions coming from under my boots. I cleaned the background with the sodium thiosulfate solution, which worked just miraculously, and now I wanted to see how fast is the explosion by stretching it over a long steel bar, so I put all of my leftover nitrogen triiodide on it and waited for it to dry, which actually didn't happen, because the metal somehow kept the moisture from escaping, which was quite sad. But even with this experiment being a failure, I think that this whole project was really cool, especially the mosquito part, and I really hope that you guys liked it, and thank you very much for watching. Like and subscribe if you enjoyed the video. Also, as always, big thanks go to my Patreons, especially Isaac Von Liu and Dangerous Lab, as well as R2D2, Ryrie Reprogul, Joseph Kudi, MI, William Bradley, Dew Nitrate, and Miss Mad Scientist. If you would also want to support my work and gain access to some exclusive content, you can consider becoming a Patreon, and see you guys in the next video.